Central nervous system provides, at first, I advise to qualify behavior, because I write main charts. And see you can see the closer to me to see more. Behavior.
وحط هناك شغله كويس بس خلاص لا
Behavior rapport.
بس
Second function, regulation, visceral function. Regulation of visceral function. Visceral function is a function of internal organs. Function of internal organs to maintain homeostasis. Homeostasis. And behavior serves like this also. Visceral functions provides behavior. For example, during physical exercise, body rises blood pressure, increase heart rate, release glucose into blood, and other. Visceral function provides behavior. So central nervous system can be divided to two parts in accordance with functions. Somatic system, somatic nervous system. Turn on behavior, on-off principle, on-off. Start or stop behavior response. And autonomic nervous system, modulates visceral function, modulation. What is the difference? On, off, start, stop, modulation, change. Not go on, not start. Because the visceral function always have tonic activity, tonic motor activity, tonic secretion of juices, saliva, gastric juices. Modulation. It means to change function up or down. Up or down. Rise heart rate or slower heart rate. Well, that's the main function central nervous system. You can read and see function, all functions central nervous system in my presentation. Now I'm going to talk shortly. The main function is integration. Integration means to combine different signals and realize it into behavior. Main function, integration. Integration. The central nervous system continuously receives signals from receptors, exteroceptors, like sense organ, eye, air receptors, touch receptors, skin, and interoceptors. Receptors responding to blood pressure, for example, glucose in the blood, mechanical stretching of smooth muscles, proprioceptors of skeletal muscles. Receptors continuously receive some signals, more or less signals, to the central nervous system. Central nervous system provides integration. signals from receptors, goal, behavior, intention, what do you want to do? To be in the at rest, or to do physical exercise, or have emotional activity, cognitive activity, mental activity. Activity goal. What do I want? And central nervous system integrates our goal, wish, intention, and information from receptors, from external environment, internal environment, and analyzes it to provide behavioral response. So work of the principles of work in central nervous system helps to understand our behavior, everything that happens with our sensitivity, pain, everything. And behavior control with cell functions also. How does it work? Central nervous system has hierarchy. Hierarchy from neuron to the brain, and from brain to the neuron hierarchy. Brain, spinal cord, as a part of central nervous system. Brain controls spinal cords always. Spinal cord transmits signal to the peripheral nervous system, and finally to effectors. Come on. Effectors. If you don't have chairs, here chair, you can take. Effectors. And internal organ. You can take this chair, I don't need. And internal organ. Excitable tissues in internal organ. Smooth muscle, heart, glands. And again, I have the two parts: somatic nervous system and autonomic nervous system. But both are combined together, work together. This hierarchy. Spinal cord has hierarchy concept also. From the higher parts of brain, higher areas, cortex area, cortex together with basal ganglia, telencephalon, then diencephalon, thalamus, hypothalamus. Come in. You can take a chair here. Chair here and take chair in another room. hypothalamus. Hypothalamus very important to control this fine function. Hypothalamus. Limbic system. Do you know limbic system?
Yes.
Limbic systems. Yes, it is limbic system.
Communication.
The brain. Next one. Brain. Midbrain. And bones, medulla. Bones, medulla. Brain stem. No brain stem. Did you study anatomy of central nervous system brain?
No,
Did you study anatomy of the brain?
Yes.
not yet. No. You studied? Oh, brain. Yes, I see.
At least primary function. We have hierarchy. Lower part of the central nervous system is responsible for simple functions. To live, only alive, to be alive. Respiration, primary part of respiration, control of blood pressure, control of mastication, chewing, eating, saliva, primitive tonic reflexes, limbic system, diencephalon, responsible to provide a more complicated control of visceral functions to adapt to behavior, for example, to emotions. Limbic system, main system, responsible for emotions. Of course, it works together with cortex. And cortex provides thinking, mental function, thinking, mind, and execution. It makes cortex makes decision. What do I want to do now? Intention, goal, intention, decisions, execution. I write main terms. We will use these terms in the next topics about motor control of behavior. And mastication and using this is motor behavior. 2 weeks, in 2 weeks we will have Pirakov conference, and my student from third course, Iranian student, will give a report about mastication asymmetry in healthy. In student with healthy teeth. Mastication asymmetry exists in 50% of healthy young people. It's a problem with motor control. You can, but I don't know about my video. Do you want to open a window? You can, but don't be sick. No? Because cool, it's not my responsibility. For me, it's not my responsibility. Don't be cool if you are cool. Or you can open here.
I'm sitting.
Well, it's common principle. About details from cortex to neuron, spinal cord, peripheral nervous system. Very opposite details about simple things and then to more complicated things. How does it work? The unit of central nervous system and nervous system totally is neuron. Nervous tissue consists of neurons and glia. Neurons. We have 3 types of principal types of neurons. This neuron is called pseudo-unipolar. Pseudo-unipolar. Why pseudo? Because this neuron has two branch to fiber, dendrite and axon merge near the body, like a single, but it's not single in the embryogenesis. Pseudo-unipolar. Next type of neuron, bipolar, with single dendrite and single axon. Dendrite or dendrite, stress. Axon and the most common neuron in the brain and spinal cord, multipolar with many dendrites, and single axon. Now we will talk about work of multipolar. Multipolar neuron is responsible for analysis of signal. To analyze signal. Here, analyze. Integration, analysis, with summation of multipolar neuron, with summation of signal on synaptic input. As each neuron, multipolar neuron, has about 40,000 of synapses on the body, and some more synapses on the dendrite. I will draw the view. Target neuron receives signals from another neuron, other neurons. For example, excitatory one, synaptic input, excitatory second synaptic input, and I will draw one single inhibitor. But really, neuron has many thousands of synapses, both excitatory as well as inhibitory. And synapses. Each synaptic input evokes only local response. I said in during previous topic that a synapse between the neuron generates local response with small amplitude. It's called EPSP in excitatory, the membrane excitatory synapses, or IPSP. So with activation, free neurons inputs, we have on the postsynaptic membrane a target neuron, one EPSP, second EPSP, and EIPSP, hyperpolarization. Each in EPSP forms electric field, small electric field, and body of neurons integrates this electrical fields. It's called summation. It's electrical summation. One EPSP, second EPSP, and IPSP. And finally, we have some result of this integration, EPSP, with more amplitude than both excitatory. But our final amplitude depends on amount, points, numbers, excitatory and inhibitory potentials. Summation of signals receiving simultaneously, like here, simultaneously, at a single moment together, is called spatial summation. It's spatial summation. Spatial summations. During spatial summation, with a lot of excitatory EPSP, excitatory postsynaptic potentials, some summary EPSP can get threshold. For example, graph of membrane potential in the axon here. This the first part of axon is called axon helic. Axon helic. Axon helic has the greatest excitability. Greatest excitability. How to say here. So the first action potential is produced on area axon helic when summation of postsynaptic potentials get threshold. Here, for example, I measure membrane potential. Resting membrane potential is a neuron minus 70. Resting membrane potential. Then neuron receives many signals, excitatory signals, with few inhibitory, excitatory signals prevails. It's spatial summations, one EPSP, second EPSP, next. Finally, it reached threshold astane. And axon helic generates action potentials. Next example. With a single synapse, I will put with single synapse, excitatory synapse, when one stimulus, one action potential followed by another with short break between them. Action potential with high frequency on a single synaptic input. So we have another type of summation, temporal summation. Temporal summation, one EPSP on the one synaptic input, next at the same with some delay, small delay, short delay, next, until threshold and beyond. And we have again action potential. It's called temporal. Temporal summation. Temporal. And spatial. Spatial here.
What's the difference between spatial and
Spatial happens, spatial summation occurs when neuron receives signal on a different synaptic input simultaneously at the same time together. It's spatial summation in space. Temporal summation when neuron receives signal on a single synaptic input on the black, but with many action potential in common. Quickly, one by one. The summation in time, therefore temporal, which is spatial, temporal. It's the main things that you must know from the first part of our topic today. Summation on the neuron. Therefore, I told you that it's very important to understand EPSP and IPSP. What is it? And ask you as a student during previous colloquium, because we will use it now. EPSP and IPSP. Summation. Well, it's enough for the first. I will print, you can take it. And then I'm going to talk about connection between neurons. Connection between neurons. What is the function of two neurons and other two neurons? Pseudo-unipolar and bipolar. The other neurons work as sensory neurons. We will talk about them with discussion about reflex. Well, tomorrow Dr. Melia is sick, and you will have class together at 8 room, Atagir Hash, 8 room, like first class. I will give punctual work with back mark, answer to me orally. Practice.
باشا دورني مع الباد مارك
For the main things, because now it's the first room, it's very important to
ايش؟
understand. Class together, prepare Anyway, you will use this knowledge.
ايش هو؟
This knowledge.
Next session, next week.
No.
Tomorrow.
No, next week. It's Nowruz, our new year.
And
And
celebrate. Bring tea, I don't know.
هذا شيء خير يا خوي لازم يكون عندك والله هذا ربحت في عيد النيروز يلا امروز شو امروز عندهم راس السنه اعملوا حفله بقى وروحوا رقصوا لا يا كبير شو عيد ميلاد خلينا اي حاجه
Connection between neurons. The principal schemes of neural circuits. Neural circuits. Neural circuits. Neural circuit means combination of 3 or more neurons to analyze something and produce a response. Neural circuit. You must know at least 2 principal neural circuits. I advise to copy. Simple. When 2 or more neurons send signal to the one common neuron, type of neuron. It's called convergence. Convergence on convergent circuit. Convergence. Convergency. When one neuron, a little correct, you see later, a little better, you see better, different synapses. Conversions. Conversions or convergent circuits. Another principle of circuit opposite, it's called divergence or divergent circuit. One neuron innervates two neurons separately. Divergence. There are principal circuits. I will draw two more, but this is main. Convergence provides, you can see, spatial summation. Spatial summation. Spatial summation. At first, spatial summation increases postsynaptic potential in the target neuron and relieves action potential. It relieves firing. Now, what is a fire? Firing is a term producing action potential in the neuron. It's called fire. From the word fire. Fire. Spatial summation increases probability of firing, action potential. Second function of spatial summations is synthesis of signals. For example, neuron in the cortex receives signals from visual system, eye, and muscles or skin, and you can connect your visual image and your tactile skin sensation. The synthesis of signal. Spatial summation increases probability of firing and synthesis of signal. Divergence. Divergence allows one signal to be propagated to a lot of muscle fibers, to increase muscle contraction, to recruit new muscle fibers, new muscles, new organs. It's called spread of excitation. Spread of excitation along nervous system. Spread of excitation. I will explain how does it work. The example with frog. Frog without brain. This frog animal has only spinal cord. Frog. Body without brain, without head. Here, transection. Body. Hand limb. Hind limb. Forelimb. And frog hunting form, and you can provoke reflex. With weak stimulus, weak small touch, with small touch here, mechanical touch, here, pin, pain touching, frog without brain. This frog will bend to the left, bending. I draw a response. It's defense response, pin, pain, and bending. Even without the brain. It works only with spinal reflexes. Involuntary, rapid, fast reflex. This reflex is called withdrawal. It's defense reflex called withdrawal. With a small stimulus, this reflex involves only stimulated leg. With more stimulus, this frog will contract muscle of both legs. Both legs will respond. With stimulation only one. With more stimulus intensity, forelimb will recruit in response. We can see motor response of all limb, hind limb, legs, and forelimb, arms. And finally, all muscles in the body and the legs contract. It's spread of excitation. With more and more stimulus intensity, more excitation due to divergence, divergent circuit, excitation can be propagated to more and more motor neuron and provoke stronger motor response. What function limits this motor response? Actually, each receptor in our body can propagate action potential to the all motor neuron and provoke seizures. Seizures is not controlled motor response and contraction of all muscles. Impossible behavior, impossible. This and inhibition limits spread of excitation. Spread of excitation limits by inhibitory process. Inhibition. So we have two processes in the central nervous system: excitation and inhibition. Excitation, inhibition. Summation and divergence increases excitation. Inhibitory circuit limits excitation and provide coordination in the behavior. The other neural circuit, one synaptic chain has divergence and form parallel chain and then convergence. As we have like ring. Due to this chain, one action potential, single action potential cannot be propagated due to small amplitude EP speed. But we can draw it like model to explain. One action potential, for example, one action potential propagated here, the parallel, and finally at the end of this chain, this circuit, the final neuron we have convergence again and spatial summation. So we have two action potentials. It allows to increase signal. And another circuit, one chain, again divergence but not forward feedback, divergence to forward to back, chain to back, and again convergence. And this chain can have circulation excitation long time until inhibitory process stops it. If you have high excitation in your brain and the deficiency lack of inhibition, for example, emotional excitation, it can repeat and repeat. And one theory of short-term memory about this circuit, it's a background to form short-term memory with long-term circulation. When you repeat some knowledge, your brain conserve memory, the long-term memory. Change this chain so to form memory. No, it's hypothesis. Here, maybe here for common function. Well, conditions. Reflex. Next part, reflex. From neural circuit, we are going to discuss about reflex. I don't print. Reflex. A reflex is involuntary action. Involuntary action evoked by stimulus, external or internal, depends on now, by stimulus and provokes motor response and behavioral response. It happens involuntarily, automatically, as a response to some stimulus. But it's not only simple response. I will explain. Do you know about knee-jerk reflex? Knee-jerk reflex neurology. Do you know?
Yes.
Yeah, I think each person can deal with it. Knee-jerk reflex. And we will in one class check your reflex, knee-jerk reflex. I have 100 neurological habits. What do you think? Is this reflex, does this reflex appear in each healthy person? Does each healthy person can show this reflex? Knee-jerk reflex.
Yes.
It must be so, but this reflex, type of hammer and extensor. Working extensor, we have a paper. But some healthy person and healthy student, commonly healthy student, don't show this reflex. Why? Sure.
Methodology classmata reflex answer to you reflex.
Brain can inhibit this reflex because brain has very important dominant center, and this dominant center, for example, brain has some problem, psychological problem, stress, and brain inhibits reflexes, not influencing on solving this problem. So stimulus is only signal, information, but reflex must be facilitated by brain. Brain makes decision to have reflexes or not. Of course, with damage of brain, intoxication, especially high cortex zones. Some reflexes exist without any influence. So reflex is involuntary, automatically, happens involuntarily, automatically by all reflexes are controlled by higher nerve areas. Higher nerve areas. There are several classifications of reflexes. We must know